What's up, guys? I'm just going to show you some Echo. Of course, it's not the full Echo, it's just pieces of Echo. This is just my development playground here, where I test certain parts of Echo. And I've been testing my masks and their operations and such on something called John Conway's Game of Life. And so I got some settings up here that I'm going to set, and I'll walk through them also. First thing I got to do is I got to press seed. When I press seed, it will generate random noise across 16 8K masks for a total of 1,024,000,000 entities. It's going to randomly choose their state. I'm going to enable this extra rule here, lifetime flip. I'm going to generate a vector mask. This will generate 67,108,864 unique vectors into a single image. And then that vector mask will be stretched over this giant mask and will tell the cellular autonoma what their maximum lifespans are, or their maximum change spans. I'm going to go in tangent mode. Just going to force everything to go circular. And I'll start it off in tiled mode. And this is a setting that we don't want. And we're good. We can press start. You can see the vector mask is generated right here. 67 million unique vector points. And then here is the full 1,024,000,000 cells, and they're actually so small that they don't even fit in a single pixel here, and so everything is scaled a little bit. I can come to here and we're going to scale everything down so we can see it. There we go. And you know, we can see things moving and we can see things happening, but it's still scaled. And so what I have here is wherever my mouse hovers over, whatever point my mouse hovers over, like if I hover over this point here, we'll see that point zoomed in, so we can see what's happening. If I click, it'll actually stay there while I go over here and I play around. So basically there's just some standard Echo mask technologies running in the background that are dictating what each one of these cells do and what they choose to do, how they mate, how they are born, how they die, which directions they want to go. Right now they're getting all their directional data from this vector mask here. So they're not explicitly being programmed to do, you know, each one of them programmed to go in a certain direction. They are pulling their directions off this big reference map here. And they kind of collate together, and I don't know, it creates like a little black hole in the center of this, which isn't really important. What's happening in John Conway's Game of Life isn't as important as the fact that 1,024,000,000 of them are being concurrently simulated all simultaneously with extremely low latency. You can see I have 0.4 milliseconds of latency, which means that I can actually go much more than 1 billion. The CPU, based on what Echo is, it frees the CPU up so that way the CPU can start streaming data from the hard drive rather than needing everything inside of RAM. And I can still obtain 30 frames per second streaming things from the hard drive and paging it. So this is the whole field here. And I have some other versions of this, but this is the biggest world record holding simulation of John Conway's Game of Life in the world so far to date, which every programming student in the world is forced to make this game and try to make it as big as they can. There are some bigger versions, but they're not full simulations. They use trickery. There's no trickery here. Each and every cell is actually being fully simulated across the entire 1,024,000,000 entities, which are all sharing the same brain and looking at the same brain, but utilizing the same brain as if it was their own brain individually. And so things get created. This is cellular autonoma. I don't know how much anybody knows about what that is, but things get created and such. Like I said, what's happening in John Conway's Game of Life is less important than the orchestration of mask data powered by Echo in the background. All right, peace out.